Hello, welcome back to the Simple Solution. Today, we'll be reviewing scientific notation. Scientific notation allows you to shorten down long decimal values. The format to writing a number in scientific notation is a.b times 10 to the power of c.
There are two main rules. The first rule is to determine the number of significant digits and determine if digital value is greater than 1.
Let's start with numbers that are greater than 1. So here are the steps you want to keep in mind. Determine the number of significant digits, and the number of significant digits is the amount needed. Number 2, determine if the original value is greater than 1. So here we have an example. So we need to see if it's greater than 1, which it is. It has 3 significant digits because the trailing zeros never count. We're going to put an imaginary decimal at the end of the number, and we're going to move that decimal to the right. You move it to the right only when the value is greater than 1. So here you make 4 jumps, and the end result, your decimal must land between the numbers 1 and 9. The decimal has to be after the first number. Moving on, so here is our converted number. Once again, we take off the zeros, leaving us with 3 significant digits only. To continue, now recall the format that we had. So we're taking our 488 and we're going to take our equation. So we're going to plug the numbers in to the specific significant digit amount. So a.b is going to become 4.88 and then times to the power of c. C is always the number of jumps that you make. So if you recall, we made 4 jumps. So it turns into 488 times 10 to the power of 4.
Now let's start with numbers smaller than 1. So for our example, we have to cross out the leading zeros because those never count, and that trailing zero after the 1 does count because of the decimal, and between the 4 and the 1, that zero is trapped, so it's significant. There's 5 significant digits. So that's the amount we need for our scientific notation. Now rewriting the problem, when a number is smaller than 1, the decimal moves to the right. So we're going to jump to the right. And then when we jump to the right, it has to be between 2 and 4. The decimal always goes after the first significant digit when less than 1. So now our answer is 2.4010. Following the format, our answer is going to be 2.4010 times 10 to the negative 3. The exponent is negative 3 because of the 3 jumps, and when the number is smaller than 1, the exponent is always negative.
Now, it's your turn. Convert the following into scientific notation. We have example number 1 and example number 2. Make sure that you pause the video to work on your own. Answers and explanations will be up next. Example number 1. So we're going to start off with a number that's obviously greater than 1. We cross out the zeros because they're trailing and not significant, which leaves us with 7 significant digits. Numbers greater than 1, we're going to add our pretend decimal, of course, and that means that we have to make 10 jumps. So now we're going to write in scientific notation. So we have our decimal after the first number, 7 significant digits, and it's times 10 to the power of 10 because we made the 10 jumps. The trailing zeros are not significant because there is no decimal.
Scientific notation, numbers less than 1, example 2. So the first thing we're going to have to do is find out our significant digits, and we have 6 because leading zeros never count. And we go back 3 because when it's less than 1, we move to the right. So recalling the format, a.b times 10 to the power of c. So our answer is 3.24570 times 10 to the negative third because the numbers less than 1 result in a negative exponent.
Thank you for watching. Like and subscribe for more videos. Until next time.